Health Samurai, so let's talk a little bit. Who is doing analytic? Okay, who is working with the FHIR data? Nice. Who is watching our working group on SQL on FHIR? The progress? Who is completely new to SQL on FHIR? Who is going to implement SQL on FHIR engine? Yeah, there are more hands. There are more hands. Okay, maybe let's start, yeah? A little bit earlier. So, yeah, SQL on FHIR, essentially, yeah, it's a steamroller, like to transform FHIR resources one way. So we just flatten it. Because we transform it one way, we just flatten, so it is limited in expressive power, but it's quite handy. So what we essentially doing is just taking some FHIR resource elements and putting into the columns. Yeah, so the view definition is a standard way to describe this transformation like flattening, so usually represented as a JSON file. But essentially it describes a transformation algorithm, how to flatten FHIR resource. And we will start what I call it functional model. So this is a set, essentially we do provide you a set of functions to describe this flattening algorithm. And to understand view definition or to implement view definition, you just have to understand and implement like 5, 6 functions. Yeah, so the first function is a column. The semantic is quite simple. You're just taking FHIR path, you're extracting elements by FHIR path and putting into the columns. So the where function filtered by FHIR path expression, quite straightforward. The for each do unnesting, so it consume collection and produce row per element in collection. So you the select usually used to cross-join between for each and parent elements. Let's say when you unnest addresses, you want to attach patient ID to each address. So you do select, and inside select you do column and for each, and that's how you do this cross-join. And there is a union all operation where you have information in different branches of resource, and you want to represent it as a table. Yeah, but we will follow through all of this function one by one, just to understand how it works, and it will be useful if you're going to write view definition as well. If you're going to implement your own engine, it is useful as well. So let's take a look at the column function. So it is quite simple. So we do describe like the path name expression. And when we run it against resources, we just extract the FHIR path expressions into columns, getting these results. Yeah, so it looks clear. There are more in specification. We do have an annotation for columns, for example, to set the type of the final result. So we do have a different modes. In a CSV mode, the result of FHIR path expression should be the primitive, but it is not required. So while you're writing the view definition, you may like get just complex data types like name, identifier. So some engines do support it, some does not. Yeah. Okay, so we understand the column function. So for FHIR paths, we decided to go with a subset of FHIR paths. So we don't want to, from the beginning, take the whole FHIR path specification, and the motivation is quite simple. We want to make it simple for implementers, because like implementing the full FHIR path spec, it's a challenge. So we decided to start from some set, yeah, and extend it with a few additional functions, like to get IDs from resources and references. Yeah, so the where function is quite simple. We're just gonna filter resources by FHIR path expression. The FHIR path expression should return Boolean result. So the for each essentially unnest function, yes. So this function get like FHIR path expression, then iterate over each over results of this expression, and produce, for example, columns. But all this function can be combined, so you can nest one function into another. So you can nest one for each into another for each, and you can nest columns into for each, and so on. So I think it's quite straightforward. Yeah. So usually for each programming language, it's a flat map. For SQL databases, it's kind of unnest or explode function. Yeah, so the select, as I told, it's a cross join. So be aware so the semantic of this function, like getting two sets of rows and cross join all of them, each record from one set with each record from another set. But usually it's used in combination with a for each when you really want to do this. You do this lateral join, let's say with a patient ID. Every name you want to join with a patient ID. So maybe there are other use cases, but I wasn't able to just invent it. So maybe John or Ryan. Okay, so union all. So union all, so let's say you may have the same information on a different branches of resource. So that, but the semantic of this function is quite simple. So it's just concatenate collections. So it's getting two collections or more collections and just concatenate. So in union all, every parameter returns rows, and we just concatenate them. If you have any question, you just can raise the hand and ask. It's not clear. Yeah. Okay. So at that point, we can play with view definitions. So I encourage you to open one of these links and try to build your view definition. So let's start from scratch. So using builder, for example. So here's a builder. We should assign some name. Let's say my patient name. Then choose the resource type. And then we can add the column expression. And let's take the ID. So we see this table. There's a special function to getting ID, but for simplicity, I'm showing you the wrong example. Okay, let's take the birth date. So, and for example, gender. So we got this nice flat view. The FHIR paths do have auto-completion. So let's take name, family first. Not first, yes, first. Yeah, so we got name, family first. Or we can try to do for each. For the name, oops. Name. Take the column, use family, and put the given join. We do support join function to join the names. Okay, and let's remove this column. Okay, so that's the sample. You may see the code in YAML or in JSON. So in YAML it's a little bit more compact. So here's some empty parts, but yeah, you can remove it. Or you can go here. Here you will have less support. Let's copy the view from this. Okay, sorry. JSON, copy. We should remove empty expressions. Yeah, nice. Okay, so yeah, with this view builder, there are some samples. Even more samples you will have on our official page. And let's maybe, do you have guys any questions on view definitions now? So let's maybe walk to the implementation, how you may implement it, or to the tests, because tests quite useful when you are trying to understand how view definition works as well. They should be very useful if you decide to build your implementation. Yeah.
Would you mind just showing the links one more time to the two different diagrams?
Mm-hmm. Sorry?
Sorry, okay. Could you show us the for each part that you did in the lines?
Yeah. So, do you mean how to do for each?
No, you were going through and building a quick example, and I just missed a little bit of it. If you go back to that page.
You mean this page?
It's going forever. It's fine.
Okay.
No worries.
Yeah. Yeah, okay, so you should give a name, you should choose your resource type, yeah, and then add the column. Something like this. Okay, let's go to implementation ideas. So there, for now we distinguish two types of implementations. One type is I call it in memory. So the general idea, yes, so there's some runtime which interpret the view definition, getting stream of resources and output the resulting transformation, result of transformation. Another approach is in database, where the view definition is transpiled into SQL query. So in this, after that, the SQL query may be used to build the view or to do some like materialized view or separate table. So from implementation point of view, it is quite easy to implement like in memory version, especially if you have a FHIR engine library for your language. So to be honest, so I don't know, we may ask Alex, if Alex here, so, but Alex didn't have a FHIR engine, so he implemented from scratch. But I think if you do have a FHIR engine, it is very easy to implement, and I will walk you through JavaScript implementation soon. So because essentially you just have to implement these 6 functions, that's all, with a quite straightforward semantic. The in database implementation, it's much more sophisticated because you are transforming view definition into some database specific SQL. There are a lot of corner cases, for example, I don't know. Let me, here, because we run on 8box, we do provide you with a final query which is generated, and there is a lot of tricks to make it work. So essentially we're transpiling FHIR path into JSON path, but it's not transpiled one-to-one, so blah, blah, blah. So, yeah. Okay, so this is 2 types of implementation. What we are expecting that like FHIR servers will do provide some type of interfaces API for view definitions. So even not just FHIR servers, yes, but analytical solution like puzzling may pretend to be FHIR servers, so you communicate with them as a FHIR server. Or we may call it like analytical FHIR server, yeah, non-transactional but analytical. So, and I think this is a topic for version 2, to work on API for FHIR server, what means like create view on the server, what operation it should provide, like expansion, like debug. Yes, so for your for implementation, here is a few steps you can follow. Just look at the existing implementation. So we do provide JavaScript implementation, and the other open source implementation you can walk through. So JavaScript implementation is quite naive and straightforward, so it's easy to start from this implementation. Yes, so the second step, we do provide you with a nice test suite. I will walk soon. So you have to write your test runner for these test scripts and test suite, and then start implementing. So, and let me show you the tests. We specifically try to design tests to be like unit tests. So for you, it is really easy, like to pick one test, implement one function, go to another test. And here is a viewer for the tests. So you see the basic test. It has some initial data set. And then you can see the simple view definition and result we do expect. So the tests by themselves are JSON files with a incoming data set, the view definition, and expected result. So, and you just have to write simple runner, which like take the data set, run through view definition, produce a result, and compare result with the expected data set. Yeah. As well, this test quite useful if you want to learn the view definition, so you can walk one by one, so and see how it expected to work. Yeah, there's a lot of corner cases covered by these tests. So it is quite comprehensive. For example, let's go and see tests for each. Yeah. So the basic for each or null. So the for each or null, yeah, I forgot to tell you about for each or null. Sometimes the expression for the for each return nothing, and because select is a cross join, it will return nothing as well. So you will lose the record. But sometimes that's not what you are expecting. So if there is no name, you just want to get the nulls in the name columns. So then you should use like for each or null, it produce empty record, which will be cross-joined with the rest, and will work. Yeah. So. Mm-hmm.
So what happens if you don't use for each or null, just use for each? Does it fail?
It will disappear. So if for each, if expression for each is null, so the whole row will disappear. Yeah. Yeah, so that's the test. And if you find any bugs or like missed corner cases, please come to us and like just pull requests of new tests. That's how we work. And I can share the experience. I think that this combination, like having good test suite from the beginning, having JavaScript implementation and the spec together, allow us to go like test-driven spec development, because we just work on a test, we work on the reference implementation, we update the spec documentation, and it is a very nice loop. So I would recommend, if you can do this for your IG, yeah, just try this approach, because it works really nice. So. Okay, so let's take a look at the JavaScript implementation. Yeah. To be honest, it is quite small. So the main file is just 300 lines of code. If you look into it, it exactly have the function I described to you, like for each column arrays, union null. Let's take inside. So this is quite simple functions. You see that for each becoming flat map. Yes, we just have to call the FHIR pass engine to get the result, and then walk through. If you understand JavaScript, you probably can go and just read the reference implementation to understand how it should work. Yeah, so the same for each and null. So just special case to return empty record. So the for column, so we just iterate every column run FHIR pass expression, and put into the role. Yeah, so quite straightforward. So here are some helper functions. So the select, it's just a cross join. So, but in this implementation, where is a inside select, but I think we will like separate it into another function. So so the union all is just concatenation. So it's almost like we just handle some corner cases, but essentially it just concatenate to arrays. So, and that's essentially all. There's some trick. Because the functional model means that you only have one function, but in a JSON representation you can put multiple keywords on the same object. So, and we should a little bit reorder the JSON representation to like get like properly nested functions. So this is a small trick. We just do the normalization. You can just look at this algorithm. I think here how it describes. So if we have for each column and a select on the same object, it means the main function is for each, and the rest is going into the for each. So if we do, and stuff like this, If we do have select union, so the union go inside select. So that's a JavaScript implementation. So after you will be able to implement it, so we encourage you go and register. So first, you can go and register your implementation in our repository. You just have to pull request the JSON object with your implementation. You see here the reference implementation for JavaScript, the 8-box implementation, the puzzling, the Google, the grams is just placeholder for gram. And the NCQA guys put. So we're expecting more implementation. So a little bit about like our test infrastructure. So when you implement your engine, so you can publish results of the test in a specific format. It is described here. Into some bucket in internet, and when you register your implementation, so you can give us this URL, and then you will become the part of this nice page, which is called implementations. And we will show you against the matrix of our tests. So. So we're expecting everybody will be green, and we will have more implementation here. Okay, so I walk through reference implementation. So I think that's all. I don't know. I'm open to answer the question, or we can write view definitions, or we can walk through JavaScript implementation.
In 8-box, can you paste JSON into the code thing? It says it's like read-only.
Sorry, can you?
In 8-box for the code section for YAML or JSON, is it read-only, or can you paste it in? Like it's read-only?
It looks like it is read-only.
Read-only. Yes, so you mean when you try to save the view?
Didn't want to just grab some JSON from somewhere else and paste it in there.
Okay, sorry, let me see. So, you mean here?
Yeah, click on code.
Yeah. Is it copy? So here.
Not the SQL tab, the code tab.
Okay.
SQL as well. But suppose you already have some YAML and you want to
The guys. I got you. There's an import operation. If you go to new definition, so this. I told the guy that people don't understand that they should go to that section. I will report them. But if you want to import existing one, so press import, and you can put the view definition here. It's just like the early beta version, so please feel free to report any bugs, any problems with this view builder. And for implementers, yeah, let's connect more implementation to the view builder. Yeah, thank you for question. Sorry. Any other questions?
I saw, I think so I think in the not in the sandbox, but I think in the view definition, there was like a SQL tab in there. Yeah.
Yeah, that's very specific for 8-box. So
Okay.
I think it's going to be the details. So because in memory engine don't need this tab.
Okay. So that's just specific for like ADOCs.
Not only 8-box, as I know, the Google guys are working on the similar stuff for BigQuery. So
Okay.
it's not yet published. I don't know, Ryan, maybe you can tell the progress when should we expect the implementation for BigQuery?
Yeah, I mean, so there is an effort that it's kind of like an experimental effort of translating this to BigQuery-based SQL as well. So I don't have an ETA on that. It's, to be frank, it's kind of something of a personal side project in that space right now. But I think that in the Google space, we really focused our efforts on what Bashir had showed earlier and the Open Health Stack flow, so that could run on cloud. It could also run in other environments. So you got to point people more towards that. But in both cases, like I think in some of these other flows as well, it is generating SQL that's specific to the system. So obviously, this is what Nikolai showed here was specific to his Postgres representation. But yeah, for Parquet or for Parquet is out there as well, and BigQuery is kind of an experiment, not something we're quite supporting yet, but hope to in the future.
I don't know, John, maybe you can comment on you, but you do not generate SQL, yes? So it's more sophisticated with the puzzling.
No, we effectively do write SQL. It's like a combination of SQL and user-defined functions within that. And it doesn't actually emit textual SQL, it emits the DSL that Spark provides. So a data frame is actually a sort of abstraction of a SQL query. But what it does is it gives you that data frame back. So say if you're using PySpark, you can then further modify that. So you can layer on additional operations onto that. And it kind of is lazily executed. So it can take advantage of the end-to-end optimizations of both the execution of the SQL and FHIR view and whatever other sort of subsequent transformations you layer on.
Yeah, we probably will rename this tab into like debug information. So every engine, if they want to provide some debug information. We just discussed with Alex nice idea that like generate C code from view definition and then compile it for extremely fast ETLs.
So could you see like this would call some sort of implementation backend service and it would return the SQL and show?
Yeah. Or let's say some implementation details, yeah, some debug information, so you can like dig into what's going on inside. Yeah. More questions? Who was able to build some reasonable view using View Builder? Okay. Who got stuck? Okay.
I think I asked the question in the main room before. If you want to have all your addresses in the same column instead of having a different row for each address, how will you do it?
You probably can like concatenate the string, yeah. So
But in
that's
which
so. Let's say you want just. Then the question, what means having addresses in a flat representation? For example, with a 8-box, we will just give you the piece of JSON.
the thing that a person will read.
Yeah. So the question is, what you mean, like having all addresses in one column?
One cell.
So, but For some flattening tricks, you may join some strings and having like addresses joined with a comma or something like this. Any other questions? Okay, so who is going to implement its own engine after this talk? Nobody. Yeah.
Yeah, there's a few implementations stuff on the Google space and in the others as well. So, I don't know, do you have a particular tech stack you're looking at? Or? Okay.
Yeah, so we do have meetings every week. The meetings are published on YouTube, so I welcome everybody to our Analytics on FHIR stream in Zulip. So you're welcome, join the meetings, ask the question in the chat. So or like reach out us personally, we are here, so ask any questions. So thank you so much.